Hello, math students, and welcome to your lesson for today. Before we get started on today's lesson, I'd like for you to just pause this video and make sure you have a piece of paper out that you're doing sample problems on and writing notes so that you have something to refer back to. You need to write these sample problems and do things as we are doing them together. So, if you want to pause this video right now, and then give these 5 problems a try. This is a review from yesterday because we're just going to keep building on the skills that we learned yesterday. So pause the video and give these 5 problems a start, and then go ahead and resume and we'll go through them. All right, what did we learn yesterday? We learned that anything to the 0 power is 1. So x to the 0 power is 1. In the second one, we learned that mathematicians say that anything with a negative exponent needs to be rewritten. And how we rewrite that is we say 1 over x to the 5th power. So we keep the same number, but remember that negative part of that exponent is gone and it becomes a positive 5. Now there's nothing for us to do, so we just leave it as 1 over x to the 5th. All right, number 3, what's wrong with that is that it has a negative 2 as an exponent. So when we're going to rewrite that, mathematicians want us to write it as 1 over, and we have the base of 4, and the exponent, it's a negative 2 now, and then remember when we rewrite it, it's going to be a positive 2. So 4 squared, so we have 1 over 16. Number 4. All right, this one's a little tricky because when we look, this negative exponent right here, this negative exponent goes just to the x, not to the 5. Remember, if there's nothing written here, 5 has the exponent of 1. So we are going to leave 5 in the numerator right where it's at, but this x to the negative 3rd, mathematicians say we can't have that, so that has to go in the denominator. So we write our factor of x and that exponent 3. So we have 5 over x to the 3rd. All right, when we look at number 5, let's see, we see one of those exponents has a negative 3, and one of those exponents is a positive 5. Well, there's nothing wrong with that positive 5, so we leave y to the 5th in the numerator, and we put x to the negative 3rd in the denominator. And as we write that exponent, remember when we move it like that, it becomes a positive exponent. All right, we're going to move on to our new information for today. And we are going to start with, we have a base of 3 and it is repeating. So they want us to write it as a base with the power or exponent. So our base that's repeating is 3. And how many of them do we have? 1, 2, 3, 4, 5. So we have the exponent of 5. All right, number 2. Looks like we have some different ways that this is split up. So if we look just inside here, we still have the base of 3, and we have 1, 2 of them. So we have 3 to the 2nd. And over here, we've got 1, 2, 3. So we have 3 is the base that's repeating, 3, 3, 3. How many times is it repeating? 1, 2, 3 times, so the exponent is 3. Okay, and we have that time sign between, and all of these are times. So how many total do we have? Well, let's look, 1, 2, 3, 4, 5. So don't we have 3 to the 5th power? So let's look at this part right here where we have it simplified, and we have 3 to the 2nd times 3 to the 3rd. How did we get that 5 if we have a 2 and a 3? All right, let's see what happened in the next one. Okay, this time we've got a 5, and there's 2 of them. And this one has 1, 2, 3, 4. 4 of them. So what happened in the last one? We had a 5. Now how do we get this exponent? Well, let's just count 1, 2, 3, 4, 5, 6 of them. And how do we get 6 from these two numbers? Okay, so what are we doing here? Another way of thinking of this, let me try another one, is if I have 7 to the 2nd times 7 to the 4th. What does that mean? If I just have 7 to the 2nd, what does that mean I have? 7 times 7. And over here, if I have 7 to the 4th, what does that mean? 1, 2, 3, 4. So my 7 is repeating. Well, how many of them do I have? 1, 2, 3, 4, 5, 6. So where does that exponent of 6 come from? Hopefully by now, you guys can see that there's a pattern and there's a rule. If the bases are the same, what are we doing? And many of you are ready to tell me that we are adding the exponents. If the bases are the same, first thing we do, keep base. You must keep that thing that is repeating, keep the base, and then you are going to add the exponents. Add the exponents. All right, let's see if we can do a couple problems here. So we have x and x, that is the same base. So rule number 1 is keep the base. Then we say we are going to add the exponents. 2 plus 7 is 9, so we have x to the 9th. All right, when we look at number 6 here, we've got an x, an x, and an x. So the first rule is keep the base. Now we're going to add the exponents, and we have to be careful because sometimes they're going to trick us and make sure we're paying attention. What is the exponent of this x in the middle? Nothing's written here. So if nothing's written here, how many x's are there? And remember, mathematicians are efficient, so we don't write that exponent. Like if I ask you, how old are you? And you say you're 13. Do you say I'm 13 to the 1st power divided by 1? No, we do not put all of those extra things in there because we're being efficient, and mathematicians are doing the same thing here. So now we keep our base and add your exponents. So now what do we have? 5 plus 1 is 6 plus 3. Oh, we get the same thing. We get a 9 again. All right, number 7, what do we have here? Bases, x, x, x. Your bases are the same. Keep the base. Keep that x. Now we're going to add our exponents. So what is negative 6 plus 3 is going to be a negative 3, and negative 3 plus 11 is 8. And if integers are difficult for you, can you grab your calculator and just do negative 6 plus 3 plus 11? So you can go ahead and do that. All right, what was the rule? Keep the base, add the exponents. All right, the last concept that we're going to talk about is something that's called a power to a power. So if you look at this first problem right here, we have x to the 2nd power. Well, that's taken to another power, so it's a power to a power. So how many x squareds do we have? Well, right here it says we have 3 of them. So I have an x squared, and an x squared. So now what does this mean? Well, this is x times x, this is x times x, this is x times x. So how many total do we have? 2, 4, 6. And what do we have to do? Keep the base. You want to keep the base, so we have an x, and how many did we have? 2, 4, 6, we said. So now go back and look at the exponents that are up here. And these exponents that are up here, do you notice anything? Is there something that we're doing with these exponents to get that number 6? All right, let's look at this one. How many, so we've got an x to the 5th, so we have a power here and a power here. How many x to the 5ths do we have? We have an x to the 5th, an x to the 5th, an x to the 5th, and an x to the 5th. So don't we have 4 of them because of this? Now I'm not going to do all of these, but doesn't this mean I have 1, 2, 3, 4, 5? Well, maybe I will do them all. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many total do we have? X is the base. And how many x's do we have? 5, 10, 15, 20. 20 total. Now, where does this exponent come from if we go back and look at the power here? So what are we doing? What is the rule? Okay, so what do we think that's happening here? What do we do? And you're right, we're going to keep the base, just like we did in the last one, but this time, are we going to multiply exponents? So when it's a power to a power, we're going to multiply exponents, and this is going to be x to the 16th. 8 times 2 is 16. All right, so what's the rule? Keep the base, multiply the exponents. Okay, so this is different. The first ones look like this, x to the 3rd and x to the 7th. Do you see how there's 2 x's here? This is when we add the exponents and we get x to the 10th. This one looks different. There's only one x and it's a power to a power. This is when we take 3 times 7 and we get x to the 21st. Okay, and the next one, the base right here is a 5. So we have 5, and now what do we do with these exponents? It's a power to a power. So we're going to take 3 times 10. So we have 5 to the 30th. Okay, so you add exponents when you're multiplying, and when it's power to a power, we multiply those exponents. Okay, the last thing we're going to do today is if you have a parenthesis and an exponent on the outside, the big thing that you need to do here is to bring that exponent into everything. Most kids have a tendency to remember to bring it in here, but they forget to bring it into that number in front. So it is going to be 3 to the 2nd, and then we have x. And now what do we do with this? This is what we just did, and we had a power to a power. So what do we do with these two? Do you add them or multiply? Well, remember when it's one base, the x, and a 4 and a 2, we're going to multiply. So we're going to get 4 times 2 and get 8. Now, do you know what 3 squared is? We should by now. 3 squared is 9, so we have 9x to the 8th. All right, second problem here. Bring this 3 in. So you have to bring this 3 into the 5. So it's 5 to the 3rd power. And you need to bring the 3 into the 7. So it's x. And remember, power to a power is 7 times 3. So now use your calculator. And this is where you're going to do 5 caret 3 on your calculator. And that's going to get you 125. And then here, remember, we're multiplying this exponent, so it's x to the 21st. So 125x to the 21st. All right, I think we have one last sample problem here, and then we'll get you going on some practice problems to do for your homework and submit. All right, bring this 2 into everything. So you need to bring it into the 7, into the x, and into the y. You have to bring it into everything. So it's 7 to the 2nd. X already has a 3, but you have to bring this in. And remember, it's multiplying when we're doing exponent to exponent, power to power. And then the y has an 8, and we have to bring that 2 in. Do you see that 2 was brought in 1, 2, 3 times? So now what is 7 squared? 7 squared is 49. And here we are multiplying those exponents, so it's x to the 6th. And here we are multiplying those exponents, so it's y to the 16th. So this is going to be your final answer. All right, you now are going to have a worksheet that is going to be posted in here. Your assignment is on your worksheet 7-3. It's going to say 7-3 practice B. I want you to do the first column. First column goes this way. So the numbers are 1, 4, 7, 10, 13, 16, 19. So stop the video if you need to, but go ahead and just do numbers. The first column, 1, 4, 7, 10, 13, 16, 19. Okay, good luck on your work.